One of the most embarrassing questions I remember a physics professor ever asking me was, does a plane that's moving in a straight line right over your head have an angular momentum relative to you? And I said, well, no, it's traveling in a straight line. How could it possibly have an angular momentum? And he shook his head at me. He said, well, I'm afraid that you didn't understand what angular momentum really is. So it turns out the answer is yes. This object does have an angular momentum with respect to you because its momentum, although it's a linear momentum, is happening at a distance r that's far away from you. And so it has an angular momentum r cross p. We're told in this problem that the airplane is 1,000 meters down the road and traveling toward you. So a little geometry tells us that r in this picture will equal 1,000 kilometers divided by the cosine of 30 degrees. So when we put in for r, we have to put that in, and p will equal the momentum of the airplane. So we come up with L is equal to 1,000 kilometers times mv times the tangent of 30 degrees. If we were told what the airplane's speed and mass were, then we would be able to calculate it. Now let's suppose the airplane is directly over our head. Does it have an angular momentum now? Well, it turns out, yes, it does. It still has an L, which is equal to rp times sine theta. Theta is now 90 degrees. And so therefore, r sine theta is just the height, h, above you. But how do we express h? Well, h is going to equal 1,000 kilometers times the tangent of 30. And it turns out that just we get back the same expression we had before, 1,000 kilometers times the mass times velocity times tangent of 30. So not only does it have an angular momentum when it's directly above you, but it's the same angular momentum. Actually, in retrospect, this should make a lot of sense. The airplane, moving at constant speed, doesn't seem to have any external forces acting on it. And therefore, it doesn't have any external torques acting on it. And therefore, angular momentum should be conserved. It should be a constant quantity. And in this case, it did come out to be constant. So, in answer to my famous physics professor's very simple question, yes, this airplane does have an angular momentum, and it has one because r is large, and the velocity vector is pointing through that r away from me.